So this is the same equation again. Okay, this one I just draw the what happened actually at the node 3 during the fast forward. Okay, during the fast during the forward pass. So what we get is this equation there. Okay, just because this is the when you want to do the backward pass, you always need to remember both function, how to express that both function, which is the input and the activation function. So this is the input function, this is the activation function, because based on that is also one way to know how to extend these rules there is by knowing both activation function and input function happen inside that neuron. Then once you know the definition, then you know which way to extend. Otherwise you will be stuck at a certain level where actually you cannot arrive at this point once you want to find the gradient of W13. Okay. Okay, now again this one, okay, this is related to this component. So in order to find this component is actually a derivative of your activating function over your net 3 there. Okay, if you talk about the net 3, and then net 3 over del net 3 over del W13, which is this one, and then if you apply the derivative, okay, then means that this one will be cancelled out, and then from here this one become 1, then you only have left x1, which is going into that direction. Okay, so if you remember that this is the definition that we have do it before during the output layers there, we said that our local error happen at the neuron 5E is this one, where actually is come from derivative of del E over del Y1 head. Same go to the E6, where actually is come from del E over del Y head 2. So this is a fresh expression of E6. Local error happen at the node 6. This is the local error happen at the node 5. So now as you can see, this one, now this one is actually my E5. Okay, this one is my E6. Okay, based on these definitions there. So now to find the del Y head 1 over del net 5, okay, sorry, this one should be 5 there, it's not 3. Okay, 5. Of course this one is come from the previous one as well. Is if you want to find del Y1 head del net 5, that one is the derivative of activation function inside the net 5, where the input is net 5. Okay, the one should be similar. It's come from the output layer derivation that we have do it before during when we want to find the gradient of every parameter that involved in a neuron inside the output layers. And then del net 3 over del O3. Okay, this one is also come okay, if you remember that net, sorry, this is not net, I'm sorry, this is not net 3, so net 5. Okay, if you remember my net 5, actually my net 5 is the input functions. This is the input function of the node or of the neuron 5. It should be W35 O3 plus W36. Let me check back. Yeah, 454 454 4504 plus bias 5, right? Yeah, this one. Okay, this one. Okay, so okay, that one. So if you want to do derivative of net 5 over O3, means that this one will be cancelled. Okay, and this one will become 1. Then what you left here is O3. Sorry, you cancel this one, become 1. What you left here is the W35. So you can see that it's a little bit different from this one. This one, you are do derivative with respect to W, which that's why you cancel this one, and then you bring this one forward. But when you do the net 5, you do the derivative with respect to O3. So that's why the one that is have been cancelled is this one, it becomes 0, and this one become 1, and the one that you bring out is W35. Okay, so the process you need to repeat the same process as your del net 6 over your del O3, and then you will find that it should be W36. And again, from this expression, the one that I call again that is come from the this is the same expression. You don't have to worry, the same expression as before. I just bring it to the center, and you find out actually this is our delta 5, and this is our delta 6, which is del E over del net 5, del E over del net 6, which is we already defined this expression in the previous slide, where when we want to do the gradient at the output layer, when we want to find the gradient at the output layer. So this is the same definition that as before. Delta 3 is still defined as del E over del net 3. Okay, again, if delta 5 is equal to del E over del net 5, delta 6 is defined as del E over del net 6. So if you talk about neuron at the hidden layer, one of it is a node number 3. The delta 3 happen at the node 3 or neuron 3 is also defined as del E over del net 3, which is equal to, okay, what is the definition of del E over del net 3? Okay, I forget to extend that. Hope you can understand the how to relate that. Okay, del E over del net 3, how to express that. Okay, okay, you can see at the blue there, delta 3 is actually equal to del E over del net 3, and del net 3 is actually del E, okay, because you have E at these two components there, you have E over the net 3 there. So del E, okay, del E, okay, E here over the del net 3 here, make this expression as our delta 3, which is similar or equal to del E over del net 3. So from here, from this component here, okay, just avoid this component, first. You will see that inside here we have the things that we defined before, which is del 5, because this is del E over del net 5, this is del E over del net 6, so it become, this one will become del 5, it's not delta 5, and then this one is called is considered as a delta 6. So if I replace that in this expression, then this one will put it here, this one is put here, and then del E over del y1 hit is that one is this one, okay, del E over sorry, del 3, sorry, I also try to okay, since you already know this is your delta 5, this is your delta 6. Now del net 5 over del O5, which is actually this one, del net 6 over del O3 is this one. So since you know, when you do derivative over this one, you get W35, this one you get the W36, then you replace it here. So this one is actually this one, and this one is actually this one. So in other words, if I replace this one and this one, then it become W35 delta 5 plus W36 delta 6. So now this is actually, okay, this component, both component here, I try to define as the local error happen in node 3, which is E3, and then this F apostrophe net 3 is because of what? Where is it come from? Yep, it's come from this component, okay, this component del O3 over del net 3, del O3 over del net 3, okay, which is this one, okay, this one. So that's why this F apostrophe, this is where the F apostrophe come from. So now from this big expression, then to find your delta 3, which is df over net 3, of course if you talk about delta 3 is this one, by okay, this the one that inside this circle, and then from the component inside this circle, you know that this is actually delta 5, this is actually delta 6, and this is actually come from the answer here is come from here, and this one is can be defined as W36 here. So that's why from here you can express in this way, where this is a delta 5 multiply with 1 W35, this one delta 6 multiply with W36 there, and then of course the one that you still not defined yet is this one. So this one is actually you already expressed in this way, so that's why you replace this one with this component over here. So from here I define another things, which is what we call as a local error happen at node 3, which is E3 there. So if I define E3 is equal to this component, now my delta 3 is equal to F apostrophe net 3 multiply with our E3 over here. Okay, I hope you can get the way to express and the way to how I simplify the component, even from started we do the change rule and the expression is very long, and how I express it into a small expression, and I change it and I added more variables and define more variables or more notation. Still the purpose is to generalize the things there. Later you see the purpose of define new things there, where if the anything you can see that now we have a generalized things there. One is that we have previously we have delta 5, delta 6 and delta 3 is actually the definition is same, still it's equal to del E over del net 3, but for local error is a little bit different. Previously at the output layer, E5 and E6 seems to be very common there. It's a difference between the actual input and predicted output, okay, for each components there. But now the error at the hidden layer, the definition is a little bit different, where it's a multiplication of my delta from delta which is the delta or the gradient come from the output node there, or output neuron, multiply with the wake that occur at that neuron. So you can see that that is defined as a local error happen at the hidden layer. Okay, then from that, this is what we get as a delta 3. So of course at the end again you want to find your updater there. The updater of W13 is equal to alpha times your del E over del W13, which is equal to alpha times the delta 3 and then times your x1, because this ex1 here is come from here. Okay, just remember that this is actually your x1. Okay, this is your x1, and then that's why you get x1 over here, because remember that delta 3 is only this component. To find del E over del 13, you must multiply your delta 3 with your del net 3 over del 13, which is this one. So now this one can be replaced with x1, which is come from over here. That's why in this expression delta 3 times x1 and times alpha to get the updater of W13. Okay,